Okay, this is take 2 on this video. So this video is for my period 4 class on Friday the 8th, and for anybody who might be absent from periods 3 or 7 on the days that we would do this. It's also for any students that are at Grad Bash that are missing class on the 8th. This is how you're going to make up whatever is happening while you're there, and I will not be there myself. So this is what I decided to do for this particular lesson is to look at our EOC Review Packet and to look at some of the problems at the end of that packet that I'm a little concerned we might not get to in our in-class review, and we're reviewing as much as we possibly can. So what I want you to do is go find your packet, and then you want to look for the problem that says in the cafeteria, sometimes salads. Okay, we want to look for that problem. So you might start at the back of the packet and just kind of go forward until you can find it. If it helps, I've got like 6 slides worth of problems here. So if you need to pause the video, just pause the video until you can find that problem. And then as we go through this video, I'm going to give you little assignment things that I want you to do to turn in that will verify that you did watch this video. And just on the honor system, don't tell somebody who hasn't watched the video what they're supposed to do, because it's going to be really easy. This is a very, very easy 100. And if you're watching the video and you're doing what you're supposed to be doing, don't give somebody else a free pass. Just say, hey, it's a really easy 100. Go do it. So in this problem, it starts in the cafeteria. Sometimes salads are served and sometimes fruit is served. Lyndon notes that out of 15 days, 12 days, salad is served, and 3 days fruit is served. So hopefully I can do this right this time and I don't have to redo this whole video. So it's out of 15 days, 12 days salad is served. Now what you could do with that is you could actually like turn that into a ratio. So 12 out of 15. If you were asked like what is the probability that salad is served, we would do 12 out of 15. And then 3 days, what is this? This is our salads number. And then out of 3 days out of 15, fruit is served. So you have a choice of fruit or salad. Most of the time it's salad though. Predict how many days fruit is served in a 180 school day year. If necessary, round your answer to the nearest whole number. Okay, so right off the bat, like we want to think critically about the problem, and we can tell, remember we're looking at how many days fruit is served. So what I'm doing here is annotating. So this is like annotating in math class where you underline and circle and kind of make some comments and notes out on the side. So if I look at my fruit, most of the days it is not fruit. Most of the days it's salad. So look at your answer choices, okay? And hopefully you can eliminate the 144 right off the bat, okay? Because it's too many days. It's too many days. Most of the time it's going to be salad. So if we're asked for fruit, it's not going to be the 144. Now the rest of those are all kind of close together that you might not be able to tell just by looking at those answer choices. Like the 144 we can kick out. So the best way to do this is with a proportion. When I taught 7th grade, I really approached that as like the year of the proportion. So proportions do all kinds of things. Now proportions are equal ratios. That is what a proportion is. Okay, it is they are equal ratios. So for example, 1/2 is equal to 3/6. Okay, that is a proportion because those are equal ratios. Now, one of the important things about our proportion is that cross products are equal. So cross products are these. They are the products along those diagonals. And if I look at this, 1 times 6, and then the other one is 2 times 3, and 6 is equal to 6. And that's the key thing about proportions that you want to know. All right, is that cross products are equal. That's the only time you should ever cross multiply. You should not be cross multiplying to multiply, divide fractions. There's some wonky strategy for dividing fractions that way. Okay, so that's the deal. So you can use a proportion to figure out this problem. It's actually the best way to do this problem. I want to know that 3 out of 15 days is equal to how many out of the 180? Okay, now pause and think about that. Don't just copy what I'm doing because you can get an A and I told you it was an easy grade. Okay, actually understand the reasoning there. I know the ratio of fruit to total is 3 to 15. Therefore, like, what would that be out of a 180-day school year? Now we use this nifty property that cross products are equal. So 15 times x is equal to 3 times 180, and that is 540. And then that turns into a simple one-step equation. So we're just going to go ahead and divide by 15. And we get x is equal to 36. And there's our answer. Okay, so answer choice B. Now, if you need to, if you're just kind of zoning out and watching this, okay, what I want you to do is pause the video and copy down on a separate piece of paper what I have up there. So 12 out of 15 is salads, 3 out of 15 is fruit, proportion is equal ratios, and then the scratch work for how you would solve that. Okay, so pause the video if you need to, and then I'm going to erase it. And we'll move on to the next one. So I'm going to clear this out mostly so I can have the space to keep working those problems. So, all right, what do we have next? We have Jean pulled, or Jean, if we're going to go like French, pulled a random sample from a population and calculated a sample statistic. Jean, or Jean, can use this statistic to draw an inference about what? Now, this is something that we haven't covered. We haven't talked about like what's a population, what's a sample, but I do believe that vocabulary is covered in like middle school, at least to some extent. And even if it's not, you do have some background. Like if I say take a sample of, like, you go to the doctor and they take a sample of blood, they're not taking all of your blood. Like, that would be freakish and bad, okay? But they're taking a sample and then they test that sample. And then population, you guys also have some background information on what population is. So we know like the population of the United States is about 330 million. We know like the population of Atlantic Coast hovers around 2,400. And so we do have some background in that vocabulary. So Jean, or Jean, is polling a random sample from a population. So polling, that means you've got a population of people, and Jean here is taking a sample from that population and asking them some questions. They do this all the time during like a presidential election. And an inference, and drawing an inference, is like, what are you allowed to conclude? Okay, so I read my answer choices, and notice that's one of the strategies I keep going back to is read the answer choices, read the answer choices, read the answer choices. A is the corresponding sample parameter. I don't know what that means, so I'm not going to pick it. Okay, I'm going to try to find something that I can, yeah, I know what the words mean. B is the population size. C is the corresponding population statistic, and D is the corresponding population parameter. I don't know what parameters are. I mean, I do, I just don't know what they are in this context. So we're going to eliminate those because I don't know what they are, and I'm not going to pick that. Now, what did Jean do with this? Jean calculated a sample statistic. So looking at these final answer choices, we have the sample and the population. So I kind of think it's reasonable that we're going to conclude something about the population. And notice that it's a sample statistic. So I like answer choice C. And that's without really knowing all of that. Stats is not my thing. And so there's all kinds of things you can do with stats, but like stats are definitely not my thing. Now, here's what's happening. So let's say in a population, we've got a population, I don't know, we'll do the population of AC, okay, which is, it hovers around 2,400 students that we have here. And we take a sample of 50 of those students, and we ask them their opinion on, I don't know, I have no idea what we have an opinion on, whether or not you should be allowed to wear hats in school. Okay, so we ask their opinion about hats. And let's say 25 of them are in favor of hats. Okay, they think hats, that's a silly rule. We should be able to wear hats in school. Okay, so 25 out of 50 would be the sample statistic. Okay, so 1/2, that's the sample statistic because that's the information we're getting from the sample. The population statistic, okay, which is the answer choice that we selected here, means that we would take that sample statistic and we would expand that to the 2,400. And so we would expand that and say, okay, well, if 50% or half of our sample was in favor of wearing hats, then we can conclude that out of the entire population of Atlantic Coast, like roughly 1,200 students, or half of the student population would be in favor of wearing hats in school. So we want to make sure that we understand like what is going on there. And I genuinely, I mean, I could go Google like what's a sample parameter and a population parameter in statistics, but I don't need to. Okay, so pause the video if you need to, and copy down like the scratch work there so that you have something to go off of. And now I'm going to actually, I don't need to erase it for the next one. So the next question is, determine which sampling method is most likely to be representative of the opinions of voters in an election race for governor of a state. So we're essentially looking at, we want it to be representative. Okay, so you want your polls to actually represent what the voters are going to do. And we've had a couple presidential elections now where like polling hasn't lined up with what people actually did. And we're not going to get into the nuts and bolts of that. So what we're looking at here is which one of these is the best way to poll people. And even if you haven't studied polling, if you haven't looked at different ways of polling and what constitutes a good poll, you can probably eliminate like an answer choice if you read it carefully. So answer choice A, over the course of a week, poll every customer who comes into a car dealership and is willing to answer questions. So we're talking about voters in an election for governor, but we're going to get those people when they come into a car dealership. So what you want to think is there a reason why maybe that doesn't really represent everybody that's going to vote? And we can debate that, but we're going to move on to the next one. Send questionnaires to 500 randomly selected members. So this is looking pretty good. Okay, so 500 randomly selected registered members of each of the recognized political parties in the state. So yeah, okay, so we'll do that. And there's lots of political parties. The two big ones are the Democratic Party and the Republican Party. Those are the two big ones, but they're not the only ones. So there are people that are libertarians and people that belong to the Green Party and people that. All right, next one, call 1,000 randomly selected registered voters and ask their opinions. Okay, so that's also random. It's got like a pretty decent sized sample there. And then D, ask viewers of the 11 p.m. news on a local television station to register their opinions on the station's website. All right, so what we're looking for here is what's the best way to get a sense of how voters are going to vote. And so what you're looking for is bias. So that's the word that, if we're going to write some words down here, we're going to write down the word bias. And we haven't covered that at this point. It is in our curriculum. It's one of the lessons that's coming up. I'm just not totally sure we're going to get there. So we're going to talk about it now. Bias is when one segment of the population is over or underrepresented. And so you're actually like tapping into one piece of your population better than you are others, and like some other piece of the population is getting overlooked. And that can skew your poll so that your poll doesn't actually give you what we call a representative of all the voters. So here's the deal with answer choice A. If you were going into a car dealership, okay, you are overlooking, kind of want to think about who might I be overlooking. You might be overlooking people like, this is like not very PC, but we're going to say people that are too poor to buy a car, too poor to buy a car, for whatever reason. Okay. So that could be, that they're fresh out of college, and so they're not going to look to buy a car at this time. People come on, financially hard times to, that's something that they do without, and they're like, okay, we're going to take a bus, or we're going to find like another way to get to where we want to go. Those people still vote. Okay. Like, those people have the knee. If you're going into a car dealership, you're really homing in on people that are buying cars, which is not all of your population. Not everybody buys a car, especially in big cities that have great public transportation. So my sister lived in New York City for several years, and the first thing she did when she moved to New York City is she got rid of her car. She sold it to me, because mine died. But she didn't have a car for years that she lived in New York City. So like, if that were like a dealership in New York City, she wasn't going to be in a car dealership. She didn't want to own a car. And so that is not a great way to get a randomly selected or a representative sample. Same with like D. Okay, so D has like slightly different issues here. These are viewers of the 11 p.m. news. Okay, so that means you're only getting people that watch the local news at 11. So we come to school really early. I do not watch the 11 o'clock news. I am in bed at 11. And I vote. So if this is how you're going to get people's opinions, then, anybody who doesn't watch local news, so maybe they only watch cable news, or maybe they don't watch the news at all. Maybe they get their news from a newspaper. Maybe they get their news from social media, which is not the best place to get your news, just going to say that. But you're going to miss people that don't watch television at 11 o'clock because of whatever their work schedule is. And so you're going to be missing big chunks of people. The other thing this one does is it's asking people to go to the station's website to do it. And that creates bias as well, because the people that tend to respond are people that have like very strong opinions. And people that are they're still going to go to the polls and they're still going to vote, but they don't feel as strongly about it. They will not bother to go to the website. So that brings us to these two options, okay? And these two are kind of good contenders because of the word random. So if you are asked a question on your EOC that asks you to pick like a good method and you see random come up in one of the answer choices, that's probably a good sign. But obviously these can't both be right. So this one, you've got send questionnaires to 500 randomly selected registered members of each of the recognized political parties in the state. Here's the problem. If you're going to send 500 questionnaires to all of the political parties, some of those political parties are going to be very overrepresented. So I am not sure in the state of Florida what the breakdown is on our political parties. Okay, but let's just say hypothetically it is 45% Democrat, 45% Republican. Okay, we're like one of those purple states where red and blue make purple. And then it might be 7% libertarian, okay? And then 2%, I don't even know what else is out there. I just know the Green Party is a thing. I don't know what their platform is. And then 1% other, okay? And all of them get 500 questionnaires. You have way overrepresented these guys down here at the end here, okay? If libertarians, and I don't know, I made these numbers up, if libertarians only comprise 7% of the population, but get the same number of questionnaires as the Democrats do, then you are getting way too much libertarian. And then when people go to the polls, you're like over counting in some of these like minor political parties. So that's the problem there. Now, 1,000 randomly selected registered voters, regardless of which party they're affiliated with. So if you select them randomly, then you're probably going to end up with about 45% Democrats, 45% Republicans, 7% Libertarians, and then like 3% like other people. And so you're not going to be overrepresenting them. So for this one, the best way to get that sample is answer choice C. So take a moment and write down like what we have here. Remember that the key word here is bias. Okay, so we're looking for bias. We're looking for over or underrepresenting somebody in our population. Pause the video if you need to, and I'm going to go click on to the next slide. All right, what do we have here? We have some kind of study going on. Don't let the volume of words throw you off. Sometimes these are really simple questions, but if you struggle with reading or like, especially if you're reading in English and English is not your primary language, you know, star these problems and come back to them, you know, kind of go find the ones that are going to be a little less word intensive. Don't skip them, give them your best shot, but know which problems are going to give you kind of a hard time and why. So it says a group researching a certain vitamin instructs a group of 100 people to take their vitamin 3 times a day, once with each meal. Another 100 people were told to keep their usual eating habits. After 3 months, the people who were instructed to take the vitamins had healthier hair, skin, and nails than those who did not take the vitamins. Which response describes the treatment group, and control group? This is more of a science question than anything else, but science and math absolutely overlap. Probably what is going to tip you off is this word control. The control group is like what we would call like the normal group, okay? They have no change. No change at all. Okay, so that's your control. Your control is the normal one. It's the one where you don't do any interventions. Like they are the group that you measure against. The treatment group, I hope is evident. Like that's the group that gets the treatment. Okay, so this would be our treatment group. These are the people that, whoops, sorry, my mouse just got kind of stuck on my desk. Okay, so all right, that's our treatment group. They're the ones that are getting the vitamin. The control group is the group that's just doing everything normally. And then the treatment here would be the vitamins. Okay, let me make sure I have that. So the treatment group. All right, so what do we have here? We're looking for the treatment group, and the control group. And we just have to like plow through this. So the treatment is having healthier hair, skin, or nails. That's not the treatment. Okay, that's the result of the treatment. That's like what happened, but that's not the treatment itself. Then the next part down, let me turn the little pointer on so you guys can see what I'm doing. The treatment group is the 100 people told to keep their usual eating habits. No, like that's the control group. That's the group that keeps everything the same with no change. So we're not picking A. Answer choice B, the treatment, take a vitamin with each meal. That's the treatment. Okay, the treatment was the vitamin. The treatment group is the 100 people told to take the vitamin, and the control group is the people that are told to keep their usual eating habits. That sounds like a pretty good answer choice to me. But when you're taking your actual EOC, even if you're sure that's the answer, like read the other answer choices just to make sure that you're not falling for like a distractor. So answer choice C, we once again have the treatment is having the healthier hair, skin, or nails. That's not the treatment, that's the result. So we're not picking C. D, the treatment, take the vitamin. Treatment group, the 100 people told to keep their usual eating habits. That's not the treatment group. So now I feel better about picking answer choice B. And take a moment, write down the notes that I have up on the screen, and I'll take. You had a question. Okay. Make sure you get those points. Those are the free points.
It seems too easy.
It does seem too easy, but it's like not. It's like free points. Okay. So I paused my video, but if you guys need to pause the video, just to write down the annotations, and then we'll move on to question 9. Question 9, Marsha wants to know what local people think about the new city tax. Okay, so let's keep in mind, like, what does Marsha want to know? She wants to know what local people think in general about a city tax. Okay, so what's she going to do? She sits in the hotel lobby and she asks the first 50 people that walk in how they feel about the tax. What type of sample is this? Now, this, like, really somebody has to define this stuff for you. So there's different sampling strategies, and I'm going to put them on the side here. I'm going to try to write with my finger instead of the mouse. Okay. So here are the sampling strategies. Random sampling, which is probably the best. And random sampling is defined as everybody has an equal chance of being selected. In other words, it's not biased. If it's, bless you, if it's of being selected, that word right there is selected. Okay. So that's what it means to be random. Okay. I mean, everybody in the group has an equal chance of being selected. Not one group is like favored over another group. Another sampling strategy is what's called convenience. Convenience. And that is what it sounds like. It's you just go somewhere where it's easy to find people. So if I were to give you guys a project and I said poll people, most of you would pick convenience sampling. You would poll your family, your friends, your cheerleading team, because those are easy people to find. Now, it might be biased depending on what you're asking them, but it is easy. So that's convenience. Self-selected is another strategy, and that's like on the previous slide where you would ask like viewers of the news to volunteer. So that would be like if Mr. Kushner puts in the announcements, we want to find your opinion on, click this, go to this website, answer this. It's self-selected, meaning that the people that respond choose themselves to respond, and that can be biased. Thank you. That can be biased because it's people that tend to respond are people that have very strong opinions. People that don't care won't respond. And then the last strategy, I hope it's the last strategy, is this. It's systematic. And this is going to be a little circular in the definition, but it's when you pick people according to a system. So it's not random, but it does tend to give you a really good sample. That would be like if we put everybody Atlantic Coast in alphabetical order, and then we picked every 5th person. Okay. It's not random because it's every 5th person on the list. So it's definitely not a random sample, but it's probably going to give you a pretty good sample of students at Atlantic Coast because your last name has nothing to do with your opinions. Okay, sounds good. All right, see you tomorrow. Great. Okay, so those are the different sampling strategies. Stratified and cluster are not vocabulary words that we use, at least not in this county. But like I would have to teach that to you, which is kind of what happened in this video. That's not kind of what happened. This was happening in the video. We haven't do that. All right. So given that, now that we've kind of gotten rid of stratified and cluster as not being options because that's there, it's not. This is either convenience or self-selected, and she is sitting and she's asking the people. So this is convenience. She goes to the hotel. And because that's a place to be, and these people are walking in, and it's easy. That's why she's doing it. It's just easy. So this would be convenience. Now, it's also not a good. It's also not a good place to go because she wants to know about local people for the city tax. So I don't know about like every hotel, but most hotels are people from out of town. Not all the time, but most of the time when people are staying in a hotel, it's because they're out of town. So this is a terrible place for Marcia to go because she's probably going to get a lot of out of town people who don't care about the city task. So who cares what their opinion is? But that's not the question. Okay. So pause the video. Make sure you write down this whole blurb of stuff there on the different strategies for sampling. And when you're done, unclick the video and we'll move on to the next. All right, this stuff is good stuff. This is sequences and series. It's kind of a cool little branch of math. Debatable, how much algebra 2 it is, but it's really cool. And I don't. Oh gosh, what do I want to tell you? We don't cover it. We barely graze the surface. Like this is kind of the extent to which we cover it. But I do want to show you that there are things that from algebra that can help you figure this out, even if you feel like it's a shot in the dark. So let's look at this one. A theater has 18 rows of seats. There are 22 seats in the first row, 26 in the second row, 30 in the third row, and so on. So take a moment and picture like what we have going on here. So here's my theater, and I have 22 seats in that first row. Then I have 26. Then I have 30, and you can probably figure out the next one because you can figure out patterns, okay? And it's increasing by 4 every time. And this is the first row, this is the second row, this is the third row, the fourth row, and it's going to go all the way back to the 18th row. Okay, so it is true. We have not covered recursive formulas for an arithmetic sequence. We don't even know what an arithmetic sequence is, okay? But we can still figure this out because we can critically think and we can figure out like what's being described here. So we have 23 seats in the first row and so forth. So as you look at that, you can draw a little picture. You guys are allowed scratch paper, so like sketch it out. And it says, which of the following is a recursive formula for the arithmetic sequence that represents the situation? I asked you, I asked you on your at-home test to Google like recursive formulas so that you have some sense of what that is. A recursive formula is a formula that uses like the previous number to determine the next number, okay? And but anyway, so just take a look at what's on the screen here, okay? And then take a look at your answer choices. Okay, I want you to notice something. Well, I'm going to pause the video and just look at the numbers in your answer choices. And then look at the numbers that we have in our little picture, like right here. And see if there's anything that stands out. I'll let you pause and take a look at that. All right. What hopefully you notice about it is that like this here, look at like 1 and the 22. The first row has 22 seats. Okay. right there. The first row has 22 seats. There is no 0 anywhere in here, so don't pick that one. Okay? Don't pick that one. I'm looking at these ones here, like how would, so don't pick answer choice A. The idea of like what a recursive formula is, like a recursive formula, okay, it always gives you a starting value. Okay, it gives you a starting value. So A and B are recursive because, and I'll go highlight like the piece of it that's recursive. Well, you know what's awesome if you want to highlight stuff is if you turn the highlighting tool on. Helps. Okay, that's the recursive piece. The other two are what are called explicit formulas. Explicit is like just, it doesn't have that starting value in it. I think these are actually the same formula though. Okay, so take a look at this. Right here, you've got 22 plus 4 times n minus 1. 22, I'm going to distribute the 4. And then 22 minus 4 is 18. And you'll notice that that's actually the same thing. So if you tinker around with that, it might kind of strike you as like, well, that seems kind of weird that those are the same thing, which might mean that you don't want to pick it because it just seems like a tricksy thing. But what I really wanted you to see when you looked at this is I wanted you to see the 1 paired with the 22. So that's the first row has 22 seats. And to match it up with the first row has 22 seats, f of 1, meaning like in the first row, there are 22 seats. So you do want to pick answer choice B. I get that when you're tinkering around on your EOC and you see a question like this and you know it's something that like we haven't covered or like we covered it in question, like one question, that it's very, very tempting to say, okay, well, I haven't been taught this, therefore I can't do it. But if you play around with the numbers, if you try to draw something out and look at this and you're like, okay, 22 seats in the first row, and then you look at those answer choices, is it guaranteed you're going to pick the right thing? Not at all. Is there a chance though that the right little piece of it is going to stand out to you and you'll end up picking the right thing? Yes. And certainly a better chance than if you just say, well, I don't know this, I'm going to bubble and see. Okay, so take that moment and play around with it. Draw a little thing. See if you can picture what the theater looks like. So once again, I do want you to pause the video and write down the key stuff there. And when you're done, unpause the video and we will move on. Okay, a couple more sequences here. What I like about this one is that this just requires you to do substitution. Okay, so we have a company is tracking the number of complaints received on its website. Wonderful. During the first 4 months, they record the following number of complaints: 20, 25, 30, and 35. So they're getting more complaints every month. This is not good. Which is a possible explicit rule for the number of complaints they will receive in the nth month. So explicit means it doesn't have that starting value, and you can tell like they look different than the ones on the previous. You guys can see it. I can't click back. Now, what's interesting about this is that you don't actually need to understand this notation in order to answer the question. All you really need to do is do substitution. So look at what we got here. We have the first 4 months. So in month 1, they have 20 complaints. In month 2, they have 25. In month 3, they have 30. In month 4, they have 35. Okay, here's what you can do. And again, it might seem like a shot in the dark, but everybody in Algebra 2 knows how to substitute in. So take 1 and plug it in for your n value, and then see what happens. Just see what happens. This is like you're playing with it. You're like, okay, I get what's happening. So take a look at this first one, answer choice A. A sub 1. Now you have no idea what that means. I will tell you what it means. Okay. You just plug it in, and just like you would normally, I'm going to plug it in both places. Okay. That is 5 times 0, and 5 times 0 is 0. So A sub 1 equals 20. Come back over to your chart. I like the looks of that. I like the 1 matching with the 20. I have a good feeling about the 1 matching with the 20. Let's try, that was answer choice A. Let's try it with B. Okay, so 20, and then 1 minus 1. And just notice everywhere I have an N, I'm plugging in a 1. Once again, we're going to have, this is 0, and A sub 1 equals 5. I don't like the 1 pairing up with the 5 as much. That's not doing it for me. Doing C here, we have A sub 1 equals 20 plus 5 times 1. Well, that is 25. I don't like the 1 matching up with the 25. I like 1 matching up with 20 is what I like. And then this last one, 5 plus 20 times 1, and that's going to give me 25 again. Okay, so even if I have no idea what I've just done, okay, I am throwing numbers around, like throw 1 in. I like number 1 matching up with the 20. I like that because I know that in the first month I'm supposed to have 20 complaints. Now, let's kind of follow up on that. So if I had to take a guess, I'm thinking I'm going to guess answer choice A because I like that. Okay. And I kind of deleted this. So month 1, month 2, month 3, month 4. Now, just to kind of check that, I'm going to try plugging in a 2 into that first answer choice. I'm just going to see what happens. All right. So then I get 5, 2 minus 1 is 1, and then 5 times 1 is 5, and I like that too. I like the 2 matching up with the 25. Just to drive it home, let's plug in a 3. So if I plug in a 3, 3 minus 1, so 3 minus 1 is 2, 5 times 2 is 10, and 10 plus 20 is 30. I am liking answer choice A. And this can come from just playing around. Just play around with the numbers. Like make yourself a little chart, okay? Like month 1, 20, month 2, and then just see what happens, okay? You have nothing to lose because if you just say, well, she never taught us this, I'm going to bubble in C, you're getting it wrong, but you could get it right. Now, just to clarify, what on earth does this notation mean? I'm going to put the here. All this means, A sub 1 means the first number in the sequence. So this means the first number in the sequence is 20. This means the second number in the sequence is 25. The third number in the sequence is 30. So the first number is 20, and that's all that that's all it means. So like A sub 4 means the fourth number in, we could say the sequence, you could say in the list, okay? That's all that means. And now that you know, now you're empowered to kind of do something with a problem like that. But be willing to try something. Be willing, like you know how to substitute. You know how to substitute. So try a substitution. All right, pause the video, copy this scratch work down, And when you're ready, unpause it, and I will erase that, and we'll take a look at the next one. Okay, this next one gets into this recursive. We have this recursive thing going on again. And remember the recursive, if you think back, the definition I gave, a recursive number gives a starting number. Okay, let me see if I can erase this up here. A sub 4 is the fourth number in the list. So write a recursive rule. Remember that has a starting value, okay? And you'll notice as you look at your answer choices, all of these have a starting value. And remember what we just said, like that little subscript means the first number in the sequence is. And so as you're looking at this, this is how you want to interpret this. The first number in the sequence is 1. The first number in the sequence is -2. The first number in the sequence is 3. The first number in the sequence is -2/3. So essentially, if we can figure out the first number in the sequence, we should be able to answer this question. I don't have to deal with the rest. So if the rest of it looks weird, you're like, what is that with like the n-1? Who cares? Okay, the first number in the sequence. So how do I find the first number in the sequence? I plug in the values. So right here, we have a sub n equals -2, 3 to the n-1. Everybody in Algebra 2 can substitute. So a sub 1. Now we know what that means. That means the first number in the sequence is. And then I'm going to plug this in. 1 minus 1 is 0. 3 to the 0. So help me, boys and girls. That is equal to 1. Okay. So a sub 1 is equal to 2 times 1. A sub 1 is equal to 2. It means the first number in the sequence is, oh, what did I do? Oh, I dropped my negative. Oops. Just so you guys can see what I did. Negative, and then I dropped it when I moved it over here. Okay, is -2. I have my answer. Okay, and I don't really care about the rest of that. I don't know what the rest of that is up to. It doesn't matter. I don't need it. Now, on your EOC, you might like not be able to pick the answer choice from this. You might be able to eliminate an answer choice. You might be able to eliminate a couple of answer choices, which is going to improve your chances of doing well. So pause the video and copy down the work, and then unpause it when we move on, when you're ready to move on. Okay. Oh, sigma notation. So much fun. It's actually not hard at all, but this somebody has to actually teach you how to do. So because you're just not gonna figure this one out. This one is particularly heinous because of the numbers in it, because it's got the fraction in it. But even without me ever saying anything, you can probably eliminate one of these answer choices. So please don't overlook that, okay? If you look at these answer choices, notice the fraction in the problem. The numerator is smaller than the denominator. I'll say it again. 1 is smaller than 5. Numerator is smaller than the denominator. So at this point, we have no idea what we're going to do with that. But C looks like an awful answer choice because the numerator is too big. Okay? So don't overlook the importance of that, because a lot of you guys automatically put down C. And in this case, C is something you probably should not put down. Okay? So we don't know what we're doing with this mess of stuff. This is called sigma notation. This is a capital sigma. Okay, this is a capital sigma. Some good stuff here. Okay, capital sigma, and what it means is to sum. So a lot of people will take the S in sigma and they'll say sum or add up. Okay, so which is what the word sum means. So capital sigma means you're going to add something up. I'll give you an example of a really simple one. Okay, that's my printed sigma. It's terrible. And I'll use an I instead of a J, but you could see an N. Don't let the actual variable throw you off. And we'll say 2 to 5, and it's like something like 2i. Okay. What that means is you've got a starting value for I, you have an ending value for I, and then you like fill it all in between. So the starting value for I is 2. So you plug in a 2 for the I. So 2i becomes 2 times 2. You got your 2i here, okay? After 2 comes 3. Okay, so you just change that to 3. And then after 3 comes 4. Don't overthink it, okay? After 4 comes 5, and that's your stop value. Okay, so I'm pointing at my screen like you guys can see what I'm doing. So we have a starting value of 2. We have an ending value of 5. And you just count like 2, 3, 4, 5, and then you stop. And then it means to add up. So you add them up. So this would be 4, 6, 8, 10. Add them up. What is that? That is 10 plus 28. 28. Okay, and that's what the sigma notation means. Okay, so you have a start value, you have a stop value, and then you have like some kind of an expression. So in the problem we're given, we have a start value of 1, and we have an end value of 4, and then this is our expression. Okay, that right there. So the first one is going to be 1/5 to the first power, and then we're going to have 1/5 to the second power, 1/5 to the third power, that's a 3, and then 1/5 to the fourth power, and then you're going to add them all up. This is best done with a calculator. Okay, like best done with a calculator. You might be able to take a stab at it. Not 100% sure though. I would not be super confident with it. So I'm going to do it out. I've got my calculator here. This I'm okay doing in my head. That's going to be 1/25. This is going to be 1/125. And then I want to double check 5 to the 4th is 625. So it's going to be 1/5 plus 1/25 plus 1/125 plus 1/625. And so I am just going to dump that in to my calculator here. 125 plus 1/1. And literally, like that's what I'm doing. I have 1/5 plus 100. I'm going to put that in. This particular calculator gives it to me as a decimal. But I know how to get the calculator to change it over to a fraction for me, and sorry, just moving this around is backwards from what it feels like it should be. 156 over 625. There we go. Not all of them are that messy, and you can do that with pretty much any kind of calculator. I usually have another calculator on my desk, but wait a minute. Okay. So this is a common model of calculator. This is a scientific, and I'm going to use that fraction button, which makes it look like that. So 1/5 plus 1/25 plus 1/125 plus 1/625. Oh shoot, 625. This calculator has awful buttons on it. So it just looks like that, and then I hit equals, and voila, there's my answer, 156 over 625. And so I know I've said many times in class, like if you don't know how to use your calculator, do that, let me know. I would be more than happy to show you, and it's really valuable because then you can do this. So pause the video, copy down the different scratch work that we have there. And when you're ready, move on. Okay, this one, which graph show, not my typo, okay, shows a sine function of a sound wave with a period of 0.002 seconds and an amplitude of 5 centimeters. And I think I had you guys look up the definition of amplitude. So period, okay, when you have a sine wave or any kind of wave, now we haven't studied sine waves, okay, so once in a while I get to it, usually after the EOC, but you will do them in pre-calculus. Honors kids like touch on them, they just touch on them themselves. But if you have any kind of like a wave, and it could be like a curvy wave like this, but I mean it could be like this, okay, a period is the amount of time for one complete cycle. So it goes like from here, and then like right here is like where it finishes the cycle and it's starting the cycle again. This amount of time is the period. Okay, so the period is the time. It might not be time, it might be like degrees or radians, like for those of you that are in IED, like, you know, we did the graphs with like, we went from 0 to 360, and the graphs like that are currently all around my room are showing one period because it's one cycle and then it starts repeating. So the period is time for one cycle. Amplitude is essentially the height. Now there's conflicting definitions. There's like something called peak to peak amplitude, but for math purposes, amplitude is usually the height of the wave. Now this you could actually get, like, they kind of give you the answer here. If you look at the info they give you, they say amplitude is 5 centimeters. So if you look at this, okay, I don't know where that is, but it's not 5 centimeters. That is jacked up. Okay, I don't know what that is, but it's not 5 centimeters. Here, if you go across, also not 5 centimeters. This one, oh my word, look at that, it's at 5 centimeters. And this one, not at 5 centimeters. So that one, they label the amplitude for you, and then you just have to read it off the graph. Probably it would not be labeled for you, so you would just have to like look at it. But remember that amplitude is simply the height of the wave, and then the period is the time for one cycle. And so you can see the period because either is fair game. If you look at this right here is where it starts repeating. That's where like the cycle like finishes, and then everything from that point on is going to be a repeat of it. And if you look at the time, you know, it matches what they had up there in the problem. And so, like, again, don't overthink these. It is possible for you to get these right even without having any instruction. You just gotta, I mean, there's a certain amount of luck involved, but there's a lot of things that you can do to improve your luck. And, you know, taking a deep breath, looking at the graphs, looking at the numbers that are on them, seeing what matches the numbers in the problem. And we are covering quite a bit of content in this video. So and I am asking you to pause and write stuff down, which is going to help you remember it. All right, last slide. These were a couple of extra things that I added on. The one thing that's not covered in this review packet is the polynomials. The year that I put together the review packet, I had the polynomials and I did them somewhere else, like I did them in class or something, and so they didn't make the packet. But I didn't want to let the review session go by without covering some of the stuff from our polynomials. So let's take a look at this one first. We're going to do state the end behavior. So remember, the end behavior is what happens at the ends, okay? And it depends on two things. It depends on the degree and what we call the leading coefficient. And if the degree is even, okay, it's like a parabola. Okay, it's like a parabola because a parabola is degree 2. like it is even degree. But anything like degree 4, degree 6, and so forth, it's going to be like a parabola. And if it's odd, it is like a line, because lines are degree 1. Okay, like that. The leading coefficient, if the leading coefficient is positive, it either tilts up or opens up. It means there's no flip. If it's negative, it tilts down or opens down. Like it does have the flip. So when you're looking at this one, the degree is 4, which is even, okay, which means it's going to be either this or this. And then the leading coefficient is negative 2, which means it's flipped. And so we would say the left is going down and the right is going down, or some kind of equivalent thereof. So yeah, pause the video there and write down the stuff for end behavior, okay? And then we'll do a polynomial division problem, if I can remember how to do it. I can do this with synthetic division. Not sure I'm going to be able to do it with the box, because the box was new to me. The box was new this year. So just like with you guys, I need to review it. Also remember other key things like roots, zeros, and x-intercepts are all synonymous. So I'm going to throw that up there. Okay, so you have some kind of polynomial. All right, those are the x-intercepts, but they're also called roots, and they're also called zeros, and I don't know what you might see on your EOC. I don't know. Okay, so for the division, we did the division using the box method, and the degree of the polynomial indicated the number of columns that you needed, and we divide like so, and we started by putting the x to the third, or like that highest one in that upper left, and then we think to ourselves. Okay, so we have to do some thinking. X, because remember, this is like rather than thinking of it as like the box, think of it as the area. This is the area model, and the area is base times height. So if the height is x, what would the base have to be? Well, the base would have to be x squared. And then the area of this box would be the base times the height. Now, here's where it got a little bit tricky, and I think I made this problem up, which means now it's going to do something weird. Okay. These are my x squareds, like right along this diagonal. I have negative 2x squared. I want negative 2x squared. Great. Why don't, not how I want this to come out, which means this has to be a 0x squared, because when we add them, we would have to get the negative 2x squared. All right, so now I have no idea what's about to happen here. X times what gives me 0x squared? That would be 0x. Great. And then 0x times negative 2 is 0x. Oh, but I want a positive 1x. Oh my gosh. Not how I wanted this to come out. I refer you to the video on the YouTube channel for better examples of this. All right, and so x times what would give me, what do I got here? 1x, I guess that would be 1, and this would be negative 2, but I don't want a negative 2, I want a negative 1, which means that has to be a positive 1, and that's my remainder. So my answer is the x squared plus 0x plus 1 plus the remainder of 1 over x minus 2. You don't need to put the 0x, so you could just write that. So there's my answer. Okay, that one is super weird because of the 0 in the middle. That was unintentional, that I ended up with a 0 in the middle, but there you go. Now, a couple of things with this, and then this video has gotten really long, so I'm going to stop. But there are some better videos. Like I know I recorded a special video. You can find it in the polynomials unit. You can scroll up in the Wakelet, and I believe it's linked in there. If you can't find it, let me know and you want to take a look at it. Now I think on your actual EOC, you might be assessed on synthetic division. If you find a synthetic division problem and it's got some like really weird looking work on it and you're like, I don't know what that work is, do it with the area model, because even with like the area model versus synthetic, so if I did this with synthetic, it would look something like this. Okay, and I know you guys don't know what I'm doing here, but okay. So I want to just show you a couple things with that. So synthetic would look like what I just did. So this is what the same problem looks like with synthetic, but I do want you to notice something. Notice, I'm going to draw a bunch of things here. Notice the 1, the 0, the 1, and then the 1 right there. So those numbers should all match up. So what you get going across the top is what the synthetic division would get going across the bottom. So if you're just patient and you do it out, you can actually match the numbers up, and you can see how that's going to work. All right, so here's what you are, copy this down, pause the video, copy down the synthetic or like the division. Okay, and then I'm going to tell you what you're going to turn in for your assignment. Okay, so hopefully you've done everything that I told you to do. And every time I said, pause the video, copy this down, you did it. Otherwise, you're going to have to dig back through this video. Have fun with that, but you did it to yourself. Okay, so here's what you were going to turn in. You were going to take a piece of paper, blank piece of paper, and you're going to write the following things down. For number 1, so put your name on it. Number 1. You're going to write down the definition of a proportion. That is from the definition of proportion. Pause the video right now. Give yourself a chance to do it. And then I will give you the second one. For the second one, I would like you to write down the approximate population of Atlantic Coast. The approximate population of Atlantic Coast. I want the number. Okay, just the number. For number 3, okay, I wrote a word at the bottom of the screen for what we're looking for when we're trying to come up with a representative sample. Okay, it is a 4-letter word, not that word. Okay, but it's a 4-letter word. I want you to write down what that is. What is it that we're looking for when we want to determine if something is a representative sample? For question 4, I gave you a definition of a control group. Please write that definition down. So for question 4, what is the definition of the control group? For question 5, I wrote down 4 strategies for how we do sampling. Write down those 4 strategies. You do not need to define them. Okay, just write down what the 4 strategies are. For number 6, I gave you a simple, easy definition of a recursive formula. Like, what is a recursive formula? Write down what the definition of the recursive formula is. The nice, super short, easy, Miss Taylor could write it on a screen definition. For number 7, what does A sub 4 mean? So if you see the A with the little subscript next to it, A sub 4, what does that notation mean? Okay. For question 8, I did this out to the side. You just have to give me the answer. What does 3 to the 0 power equal? What does 3 to the 0 power equal? For question 9, when you have sigma notation, okay, that's that big funky looking E thing, okay, there's a number at the top. What does that number represent? What does that number mean? It is the what, okay? And you should have written it down because I had the big sigma and then I had little arrows and I said this is the number at the bottom, this is the number at the top. What's the number at the top? For question 10, define period, the period of a wave. What is the period of a wave? I gave you a nice, easy definition, not crazy college level definitions, okay? For number 11, just fill in the blank. You only have to write the blank at the end. Odd degree polynomials behave like a what? A blank. Odd degree polynomials behave like a what? And then for question 12, copy the box. It's still in front of you if you're watching the video, so everybody should get that one. I want you to copy the box. All right, and like I said, this should be an easy A. This is just about watching the video, taking the notes, copying what I told you to copy, and then putting it on a piece of paper. Take a picture of that piece of paper and upload it to Focus. If you are not able to upload it to Focus, you may turn in the hard copy, okay? But this is an easy A. So if your neighbor wants to get out of watching the video, okay, because they don't want to do it, give them all the wrong answers, okay? Because they're being lazy and they're trying to use you to get them to do their work. Okay, so upload that to Focus. I know this was really long, but it needed to take up about 90 minutes of a class period. And for those of you that are absent or were absent or went to Grad Bash, you need to make this up because this is probably the only time we're going to go over these problems. Okay. All right. Sorry it was so long. I know that's like a super long lesson and lecture, but you know, it is what it is. So let me know if you have questions about what you need to do and I will do my best to answer them.